list. Drex, you're from the Cybercrime Investigation and Coordinating Center in the Philippines, and is going to be talking to us about AI on the battlefield and how you can build trust and accountability through digital forensics. So I'm hopeful this is a clear and very useful follow-on from the previous presentation. Same applies as last time. Please do leave questions on the Slido so I can come to those at the end. Don't leave it all up to me, or I'll just ask all the things I'd like to know and everyone will miss out.
Okay, good afternoon, and today we would like to talk about the use of AI in the battlefield and how do we build trust and accountability through digital forensics. As just a side plug, this talk is highly aligned with the brochures, or sorry, the materials been given out outside, so they'll be very helpful. Next, as a forensics practitioner, we always look for potential electronic evidence or artifacts from different levels of where information could be stored. And as such, we always look at, for this topic, we will be looking at 3 different levels of how AI is used in the battlefield. On a strategic level, AI could be used in a nation versus nation cyber war, wherein AI-powered malware, disinformation, misinformation, and deception are used with the less violent designs of crippling economies, manipulating political views, undermining the authority of a state, disturbing a state's relationship with its allies, or the use of AI to reduce a state's military efficiency, if not their effectiveness in physical combat domains. Additionally, AI could be used to equalize the fighting capacity of richer nations to that of smaller nation states. Additionally, AI could be used to deny access to a nation's critical infrastructure so that another nation can dictate actions of the victim nation. Now, on another level, the use of AI could be by the military commanders for their data fusion and integration platforms. AI can easily ingest and integrate massive amounts of disparate data from hundreds of thousands of sensors simultaneously, as well as deal with the velocity and amount of intelligence reports that can come in real time, as well as from open source information, as well as logistical data for the commanders, in order for the commanders to see a unified real-time operational picture. Battlefield commanders could also use AI for analytics and decision support systems. This could be for threat detection and early warning for their troops, target identification and prioritization, as well as resource allocation and logistics optimization. Also, AI on a more mundane case could be used for predictive maintenance of their equipment and to assess their readiness in combat. Now, the one that is catching most of the imagination of moviegoers is the use of AI by battlefield forward forces. This could enable these tactical units for advantages for violence of action. They could have battlefield awareness, as well as drone tasking and swarming, as well as automate drone analysis from all these hundreds of thousands of sensors coming in at the same time. It could be used for communications and coordination, but one of the things that we are looking at, for example, as announced by Palmer Luckey from Anduril, would be personalized threat assessments and prioritization. In a public show, he mentioned that, for example, you have sensors coming in, data coming in from tanks, from armored personnel carriers, as well as from CCTVs in head-mounted displays of individual soldiers. Let's say that soldier is walking, trying to clear a room in an urban environment. The AI sensors, through visual analysis or audio analysis or open source reports or intelligence reports, may be able to detect a sniper taking aim at that individual soldier. Now, the soldier in his heads-up display would not only alert the individual soldier, but also tell the soldier what part of the room to roll towards so that the soldier will be out of harm from the threat of a sniper. Another one that Palmer Luckey from Anduril mentioned in another show was that AI could be used for fire control systems on all weapons, not just on tanks, on armored carriers, but also on the individual rifles of each soldier. So, for example, you have a urban environment, and then you have infantry, crisscrossing the line of fire of each other. When a soldier pulls a trigger, the AI will wait for the optimum time to actually fire the bullet. That optimum time will enable to not only hit a moving target from far away, but also avoid friendly fire. So that's one of the uses of potential AI. Now, with all that said, from a law enforcement perspective, AI could be misused in several ways. The first one we imagine, would be unlawful targeting. You can have AI-driven autonomous weapons and decision-making systems that may misidentify civilian targets or violate distinction principles. Another way of violations would be the loss of human oversight. This can happen when AI systems act independently without meaningful human control. This could lead to unintended strikes or excessive force, especially on civilian populations. The third way we imagine AI could be misused is when there is disproportionate harm to civilians. This can happen when there is inability of AI systems to apply proportionality assessments. The fourth way we think AI could be misused on the battlefield is for the deliberate use of AI systems for war crimes. This could be AI-enabled tactics such as autonomous massacres or deepfake information like red flags or false flags, to justify unlawful actions, or even AI-driven psychological torture. Now, with all that said, the realization of AI use in the battlefield raises critical concerns. The three ones that have been mentioned over and over today would be trust, accountability, as well as expectations for compliance to international norms. Now, with all those critical concerns, key issues are raised. The first one is explainability of the AI systems. Another one is, how do they mitigate bias? And the third one would be, how do we monitor the AI systems are compliant to international humanitarian laws and international human rights laws? Now, one solution that we propose from a law enforcement perspective is accountability through digital forensics. This means that we should have systems that can verify if an AI's output was grounded in lawful procedure or if it ventured into misuse and bias. It also means for us that this would reinforce adherence to international human rights laws and international humanitarian laws. So this could answer one of the issues that were raised earlier, like on regulation. This would actually help self-regulation. Now, the use of AI is not a question of when it should be used, but more of how it should be used. We propose that AI should be trustworthy in at least 3 domains or 3 factors. That would be to build trust in state actors, to build trust in the technology behind AI systems, as well as to build trust in the people behind those AI systems. So just to define, state actors would enable responsible AI governance and approaches and solutions. We would need depoliticization and exchange in good practice among nations. And there should be confidence building measures that foster state trust. We would be talking about in the next few examples about this. One example, though, for now, is that nation states should demand from their vendors that they should have some sort of chain of thought documentation so that nation states could avoid accusations of unlawful or disproportionate force. The next type of trust that we should be looking for is technology. So in here, we mean that we should be able to verify the reliability and performance in operational context through systematic testing. One example of a test objective is that AI systems should be developed that can distinguish civilians from combatants or weigh proportionality in different scenarios. These systems should be auditable. One way of doing that is to have explainable AI that should enable operators and external parties to see why an AI made a decision in a particular scenario. The next one would be trust in the people, because trust is essential across operators, commanders, and the developers of those systems when deploying AI-enabled military capabilities. There should be confidence in vendors, and there should be practice of due diligence to minimize risks and ensure responsible governance of these technologies. For example, whenever feasible, states should release summaries or explainable logs to reassure not only their citizens, but other citizens of the world that no violation of human rights laws has occurred. Or if there were violations, accountability measures should follow. Next. Now, we recommend for this talk at least 5 items. The first one would be to translate legal or ethical norms into technical requirements. This is because we see a problem wherein you have this abstract international humanitarian laws or international human rights laws concepts like distinction, proportionality, precaution, and for programmers, they rarely map directly into source code or into hardware specifications. Now, the problem is that developers may not know how to implement meaningful human control, that is a lawyer term, or bias mitigation in practice. There is a disconnect there between developers and legal talk. Now, an example scenario where this is a problem is that you may have a lethal targeting AI drone or robot that nominally aims to minimize collateral damage. However, in reality, if the system's software doesn't require, for example, a confidence threshold or real-time revalidation of civilian presence, then we say that the design is incomplete. Now, if an incident occurs and non-combatants are harmed, then investigators will find that the core logic behind that AI system is flawed. Okay? And we will find that the logic never integrated any explainable gating system to show when it flagged the target is false. The role of digital forensics in here is that a post-forensic audit might analyze the log showing no explicit caution loop, or if the system was explainable AI, it would be evident that the AI used insufficient data or had missed critical evidence of civilian presence. Now, this clarity would involve embedding explicit legal norms into the system's architecture. I'll go faster now. So the next solution, recommendation, is to identify red lines. This was mentioned earlier, and understanding general intelligence myths, artificial. The problem is that in red lines, in defining red lines, it is sometimes overshadowed by fear-mongering about unstoppable AGI machines, which distract from near-term concerns and more realistic concerns like unverified autonomy or biased data. Because if there is no clarity, these red lines may be ignored. Now, scenario, for example, there is an AI takeover of a town. And there is a scenario wherein drones or a robot's facial recognition misidentifies civilians with similar clothing as militants. The public will blame advanced general intelligence, but in forensics will reveal that it's simply a design flaw and that there has been no thorough explanation of classification decisions or built-in any safety checks. Next. The third recommendation that we have is regulatory alignment and mutual recognition. This happens because we see a problem with inconsistent or disjointed regulations across nations and industries where AI developers adopt minimal compliance in certain jurisdictions, risking widespread mismatch in oversight or accountability. A scenario where this may be a problem is that let's say a robot built under nation A would include transparent logs and explainable modules. Now, nation B will buy the same devices or products or robots from the same vendor, but this nation B would have weaker standards and omit those additional expensive features. So now if a war crime happens on nation B, investigators will not be able to gather the same level of forensic data. The result in a digital forensics case, there will be partial or inconclusive accountability. Next. The fourth recommendation is the monitoring, evaluation, and enforcement and verification procedures. This happens because we see a problem wherein frameworks or guidelines may be insufficient if there's no robust way to monitor real-world usage, enforce compliance, and verify claims of lawful operation. We see a scenario this happening when, for example, a state claims it only uses human-in-the-loop AI for targeting, and then a non-government organization obtains evidence that submissions of this robot engaged fully autonomously in violation of international humanitarian law. Now, forensics can play a role in here by checking the engagement logs of the robot, and they may find that the operators, the human operators, did not receive any final alert and may contradict the official statements of the military unit. The last recommendation for today would be cross-sectoral dialogue for trust building. This may happen when you have isolation among member states, nation states, among the private sector, and you have civil society distrust. You could have misaligned solutions with different priorities and different budgets, and therefore you will have problems of missed opportunities for synergy or oversight. Let's say in a given scenario, you have a group of people having a multinational tabletop exercise, and that group would include an AI vendor, a human rights non-government organization, and various participation of various military agencies. Now, during the tabletop exercise, they discover that the video feed or explanations for target identification, wherein the AI highlights certain features of vehicles or uniform, is quite unreliable at night. Now, the result of that tabletop exercise, the group will then propose a standardized low-light data set and more robust fail-safe mechanism. Next. Now, here is where we emphasize the role of digital forensics in the use of AI on the battlefield. Digital forensics provides an actionable bedrock of accountability. Forensic evidence will pinpoint whether an AI system adhered to or contravened ethical and legal benchmarks. Now, courts and tribunals can rely on forensic records for unbiased evidence to ensure that any sanction or exoneration stands on clear legal ground. The core functions of digital forensics for this case would be for evidence collection, root cause analysis, and preemptive compliance. As a conclusion and as actionable items for this group, we need to build trustworthy AI systems. Explainable AI designs plus rigorous digital forensics foster real-time checks and balances in the systems. This can ensure that advanced battlefield capabilities do not overshadow moral and legal responsibilities. This will help us build the future when we have nation states, vendors, and NGOs collectively investing in aligned policies so that, for example, one robot used in one country can produce evidence that can be easily understood or appreciated in other jurisdictions. Additionally, cross-sectoral channels like this, like RACE, should remain vital for testing emergent best practices and forging trust around the world. Now, AI on the battlefield need not to be a cause for fear if we embed trust and accountability at every step. Thank you.
Thank you very much, particularly for ending on a positive note. It's always difficult sometimes in these scenarios to end on a pro rather than a con, and an opportunity and not a risk. It's fantastic to see how talking about forensics here as a means of actually improving, as I understand it, the opportunity to design tools, systems which actually are more compliant, safer, less risky. I would be interested if you could perhaps summarize a little bit, and perhaps a clear kind of chain of thought, how forensics can actually inform or offer insight to different stages of the life cycle through design, deployment, operation, then recycling around to the beginning again. A couple came out, and I'd love to hear some more thought on that if I could.
I'm trying to imagine somebody is being prosecuted in ICC. Would that work? Well, if we were investigators, one of the first things we would be looking at is the documentation of the AI and how it was sold to the military unit or to the agency. And then we would be looking at test results. Perhaps if a company like AI, the previous one, was contracted, we would subpoena them for records of how did their tests go. And let's see, and then based on those test results, we would see how the developers tried to fix the problems. And if they did not fix the problems, then that there might be some sort of at least negligence on the part of the end user, and that would be punishable. And then after that, we would also be looking at the data, the training data that was used, looking at the weights on how the AI system was biased or not biased for certain scenarios. And then we would also be looking at the source code as much as possible, interviewing the developers of the AI system, looking at the libraries, open source or not, that were used, looking at the research papers that were referenced. Basically, we would be looking for stuff that may or may not prove negligence, and also look at the logs. The logs would be the last things to be looked at. If there was an override function, that would be malicious in nature. Or if there were other communications that said that the AI should have a backdoor, that if the system, if the scenario happens, this would happen, an autonomous massacre should happen. So a lot of things come into mind on how we may prosecute somebody in behalf of the ICC, for example.
Brilliant. Thank you for that. I have one more broad question from me before I turn it over to the questions that I've been receiving from the audience here and online. And that question is very broad, but do you think, in your opinion, has the usage of AI in the military domain made forensics and holding accountability through forensics easier or harder?
Right now, harder. For two reasons. A lot of military agencies have put their weapons under secret labels. And not only are they secret, but they're also compartmentalized. And the problem with that is that investigators do not have access to many information. Another one is the complexity of AI systems. We're looking at hundreds of billions of parameters for large language models, for example. At any given time, it's quite difficult if they do not have explainable AI built into the system. It will be quite difficult to figure out how an AI system is thinking at a particular moment. There have been ideas of looking at the neurons, for example, at any given stage, or looking at the logs generated by AI. But you need another AI just to read the volume of logs that have been generated. So it's difficult.
I did think that perhaps was a leading question, but that's not an unexpected answer. There are a number of questions that have been offered from the audience, and a number of them actually overlap. So I'm going to kind of condense those together. A lot of them come down to the question of, do you think that in the current trajectory of development and deployment, that explainable AI and those that produce the kind of records and logs that you require to do the kind of forensic work you're talking about, do you think that's the trajectory we are on, or do you think that there needs to be an effort to ensure that we actually shift onto one where those logs and those tools and those resources to do good forensics are actually made and created?
Right now, it's not a trajectory that we are on, simply because there's not enough public pressure on AI developers to enable those features. Also, the reason why AI vendors don't do that on their own, out of the goodness of their hearts, is because of the cost of the computing power involved to use those features.
So another question from the audience here, which I think hopefully you can offer some insight into, is we've obviously talking to a very international audience and talking about digital forensics as a methodology. Is this a standardized approach, or is there diversity in different approaches taken to digital forensics? And how might you or we try and take that diversity and create harmony in a single acceptable approach for all parties?
That's a great question. Well, we are trying to standardize approach across different nation states, especially when it comes to recognition, for example, of chain of custody or recognition of electronic evidence across different states. One of the first steps that we have done is to ratify the recent from UNODC, the Convention of Cybercrime. That is something that is a a step forward to that, but we're not there yet. We're not in a ideal situation yet.
Brilliant. So another question is, there's a lot of questions about the viability of explainable AI. So I'm going to condense those together. So is this a linchpin? Without explainable AI, is there no way for digital forensics to actually operate as the way you've described it as a useful tool in this space?
There would be less evidence that can prove beyond reasonable doubt a crime has happened. Without explainable AI, there will be lots of circumstantial evidence. There will be lots of prima facie evidence. But beyond reasonable doubt would be harder, and that would require much more good old-fashioned detective work for prosecution.
Good old-fashioned detective work through thousands or millions of lines of code and logs and what information is available, which is obviously not an enviable position to be in. I want to come back to a point that you raised in answer to one of the previous questions about the bifurcation between open source versus closed source. Do you think that open source provides an opportunity for that creation of a more explainable form of AI if open source becomes a more commonplace usage in the defense sector?
Yes, open source, the use of open source libraries and tools and research can really help accelerate a digital forensics process, because you don't have to subpoena or have a search warrant executed on the premises of a cloud service provider or the AI systems vendor, which may be in a different country. If there is open source, at least you could have great ideas on how the system works, how the system thinks, and then you could, write your own tests or write your own, at the very least, your own prompts to see how a system thinks, and then probably predict how it behaved in a certain scenario.
So a question which builds almost directly on part of your answer there in terms of a jurisdictional one. Could you describe what the current state of affairs and perhaps the ideal future state of affairs is with regards to jurisdictional access? How do you describe it right now in terms of getting a hold of the data and the forensics material? And how might you view it as in the future, and how do we get to that future?
Oh, wow. The current state is hard. It's already hard to explain how a computer works in different jurisdictions, much less try to explain how an LLM works or how it differs from CNN or LSTM and stuff like that. And then you have to try and get the judge, if you're executing an extradition request, for example, in another country, they would have, through mutual legal assistance treaties, they would have to go, your person from nation A would have to go to nation B and explain to another judge there, this is the evidence we have, this is our chain of custody. And so it's kind of hard because the AI development is progressing so fast that the judicial systems cannot keep up. We joke a lot of times that we are working on 22nd century crimes with 20th century laws based on using 19th century tools.
Well, I think on that fantastic soundbite, we might leave the panel there. Please, audience, help me thank our panelists for a fantastic talk and question.
Thank you.